set off coloured lights. Hit a key and a colour would appear. Rumford called this device an optical harpsichord. He never actually built one. It was too difficult with 18th century technology. It took 200 years for Rumford's dream of light and music to come true. But back in the late 1700s, people were observing more and more aspects of light and colour which they had no way of explaining. What had caused John Dalton's colour blindness? What was causing Rumford's coloured shadows? What was needed was a breakthrough in the understanding of what light is. And that breakthrough came in the early 1800s, but not from someone who was investigating light, but from someone investigating sound. The hero of this story was a wealthy and precocious Cambridge medical student called Thomas Young. Now, as a member of a college, and a wealthy one at that, Thomas Young liked horse riding, he liked music, and he liked placing bets. And there's a bet recorded in the gambling book at the college that Thomas Young, as a student, bet that before he graduated, he would write the best essay ever on sound. If you listen hard to organ pipes, you can unlock the mystery of how sound travels. An amazing truth about light would be hidden in Young's essay about sound. His initial interest was to investigate a fact that people had known since antiquity. Sound travels in waves. For instance, columns of air in organ pipes vibrate up and down, rather like ripples of water going back and forth in a lake. Young studied the unusual and distinctive ways in which sound waves behave, particularly when they overlap. Imagine that you play a single note on the organ, and it sounds pure. Now, if you add another note, which is out of tune, you begin to hear beats, which are related to the difference in frequency between the two notes. Two waves meet. They can either add or subtract. You get pulses of addition and difference. Young now made a dramatic leap of imagination. He realized that light must work in the same way that sound does. If you shine a beam of light through a card with two slits in it, as the two light beams emerging from the slits recombine, you see a pattern of bright and dark bands. The two beams of light cancel each other out in places, just as the two sound waves do. That could only mean one thing. Light, like sound, was a wave. Today, everything from fibre optics to spectaclism is based on the idea that light is a wave. But at the time, it was an incredible idea. From Newton on,
The existing notion of light was that it was a stream of tiny corpuscles or particles. Young's radical idea was greeted with howls of derision. Young's new theory that light travelled in waves was very controversial. It was going against 150 years of thinking of light as a particle. Young hit back, and the example he used was that of a pond. Think of waves travelling on the surface of a pond, and you could see the way light moved. His watery model of light was a powerful argument for a new wave theory of how we see and how light travels. It took a few decades, but people realized that waves can explain a whole host of previously inexplicable optical phenomena. The idea that light was a wave is now heralded as one of the great discoveries of science. It meant colour was at last comprehensible. Just as different frequencies of sound give you different notes, different frequencies of light give you different colours. Young experimented with spinning colour wheels, and he saw that if spun fast enough, just 3 colours, red, green and blue, can combine to appear as white. What Thomas Young concluded from this is that the vast panoply of colours humans think they see come from combined